Hey everybody, this is a video for my grade 12 40S pre-cal students. What we're going to do is we're going to go through this this little investigation slash warm-up together. Got to use your calculator for this. We finally hit a part of the course where we really need our calculator quite a bit, at least in this section. And this is going to introduce us to the fabulous world of logarithm mathematics. So, first of all, use a calculator to determine the decimal solution or approximation of this exponent to one decimal place. Well, you know what? I don't think I need a calculator for that. 10 times itself how many times makes 100? That's pretty easy. X is 2. 10 times itself how many times is 1? Well, I remember from grade 9 that any base except for 0 to the power of 0 is 1. So I know that x is 0. But how many times do you have to times 10 by itself to get 8? I mean, 10 to the 0 we just said is 1, and 10 to the 1 is 10, so I can kind of conclude that it's between 0 and 1. This x has to be something that's a decimal. It has to be between 0 and 1. And I'm kind of guessing it's probably going to be closer to the 1, since 8 is a little closer to 10 than it is to 1. In fact, it's quite a bit closer. So I'm going to start by just guessing and checking. So guess and check. Maybe I'll try 10 to the power of 7. See how close that gets to being, or sorry, not 7. 7. That'd be that would be 10 million. 0.7. Sorry about that. So yeah, 10 to the power of 0.7. Let's see what that is. 10. Everybody should know where their power button is, right? It's usually x to the y or y to the x on most calculators. So 10 to the power of 0.7. And oh, that's not very close to 8 at all. That's quite a bit smaller. So I'm going to jump all the way up. I'm going to go past 0.8 even. I'm going to jump to 0.9. 10 to the power of 0.9. Oh, even that's not big enough. It's close. How about 10 to the power of 0.95? Oh, too big. I'm close to 9 now. How about 10 to the power of 0.91? Oh, still a little bit too big. How about 10 to the power of 0.905? Oh, that's close. And you're probably already going, Kello, you were only supposed to do one decimal place. So yeah, good enough. That's going to be too small. So what I actually want is something around 10 to the power of 0.904 something. But x is equal to 0.9 because it did only want one decimal for the answer. So that's a good enough approximation. Now, suppose I had more time on my hands, and I actually did try 0.9049, 0.9048. Would I ever get exactly 8 and no decimal on it? Think about that for a second. You're probably going to realize, no, you won't. Because what kinds of numbers are we dealing with here? Well, let me refresh your memory. Think about what 4 to the power of 0.5 is. You're probably going, I don't remember what 4 to the power of 0.5 is. How would I know that? Well, actually, yes, you do know that, because that's the same as saying 4 to the power of a half. And you should remember from grade 10 that that's the same as saying the square root of 4. So you should know exactly that that's 2. But that's only a whole number 2 because 4 is a perfect square. Try this with 2. What's 2 to the power of a half? And you're asking for the square root of 2, which is 1.414, blah, blah, blah. Remember what we call those kind of blah, blah, blah numbers? Irrational numbers. So yeah, I could have done this forever, and I'm never going to get exactly 8 because I'm dealing with irrational numbers. So let's keep that in mind. Now, we got a chart to do. Y equals 10 to the power of x when x is negative 1. I don't need a calculator for that. 10 to the negative 1 is a tenth. 0.1 if you like decimals. But I have no idea what that is off the top of my head, so I'm going to punch buttons. Sorry that I get these weird shadows coming off of the stuff here in my calculator. So 10 to the power of negative 0.3. I'm going to make a little point here. Some people goof this up because they have very fancy calculators and they got into a bad habit of using minus when they mean negative. On the fancier calculators, if you're just doing basic arithmetic, your calculator will figure out whether you mean negative or subtract based on the context of what you're typing in. But in this case, I think even the fancy calculators need to be told negative, and I don't think for most of them that using your minus sign kind of lazily like that will work. So make sure you type what you mean and you mean what you type. And I just did the wrong thing there. I wanted 0.3. Negative, why don't we just start over? 10 to the power of negative 0.3. Well, isn't that interesting? It's about half. So, and we want, I guess we'll just go to one decimal place, so 0.5. I don't need a calculator for 10 to the power of 0. I do need a calculator for 10 to the power of 0.6. I have no idea what that is. So 10 to the power of 0.6. 3.98. So if I round to one decimal place, that's 4.0. And for 0.9, well, we kind of know that answer already. I'll punch it again. But 10 to the power of 0.9, we already kind of learned, is close to 8. 7.9, good enough. And I don't need a calculator for 10 to the power of 1, and neither do you. So there we go. Now, I actually put a note on my blog. Please ignore. I meant to not have any graphing in this part of the unit. We're going to skip the graphing for this chapter. So copy and complete the table for the inverses of these. In other words, what if instead of y equals 10 to the x, what if it was x equals 10 to the y? So now these become the answers. What are the exponents? Or these become the exponents. What are the answers? Well, notice it's basically just going to be the same thing reversed. The x and the y switch spots. So this will be 0.1. This will be 0.5. This will be 1. This will be 4. This will be 7.9. And this will be 10. So if I did graph these two charts, I would actually get inverse lines of each other, which means that they actually would be mirror images reflected across the line y equals x. All right, number 4. Let's use our new log button. Well, there's nothing new about the button. It's new to us because some of you have probably never used it before. Let's use the button that says log and see what we notice about these answers. And what does taking the log of a number do? Why is the log of 100 equal to 2? Is that true? Let's see. Log, where's log? Log of 100 is 2. Isn't that interesting? Now, some of you might have to punch that differently than I did. Some of you might have to put the 100 on the screen and then hit the log button. Okay? I do it the same way it's written down. What if I said log of 10? I get 1. What if I said log of 1,000? I get 3. What if I said log of 1,000,000? I get 6. What's going on here? What do you think log means? Sometimes when I'm doing this with a class, they'll say something like, well, it means just count the zeros. Well, maybe that's true for this. But what does it mean for all the other ones? Log of 1 is going to turn out to be 0. Interesting. What's the log of negative 1? Okay. Log of negative 1. Error 2. Error 2, by the way, is a domain error. That means I punched something that is impossible to do, not within the domain of the function. So, undefined. How about log of 0.1? This will be interesting. Negative 1. Does that look familiar? Doesn't it look like these two answers here? All right. So, oh, and I guess I missed the very first one. What is the log of 0.5? So the log of 0.5 is negative negative 0.301. Oh, let me count. Let me just. And does that look familiar? Oh yeah, that's this column here. So the log of 0.5 is negative 0.301. What does that mean? Well, any ideas what taking a log of a number does? Taking a log of a number is like asking the question, how many tens do I multiply together, wish I had more room, to produce that number? That's what a logarithm is, right? How many 10s do I got to times together to make 10? I just need 1. How many 10s do I got to times together to make 100? 2. Take 3 10s together and I get 1,000. 4 makes 10,000. How many 10s do you times by itself to get 1? None. That's just the weirdness of the power of 0. Notice I could times 10s together forever. I'm never going to get a negative. So that's not even possible. And I times 10 by itself -1 times, because 10 to the -1 is 1/10, which is 0.1. So this is like the opposite question of that. The log of this is that. Hopefully you're starting to see now the relationship between exponents and logs. They're inverses of each other. They're opposite operations. Okay. Oh, that kind of explains this guy too, right? 10 times itself 0 times is still 1. So I need 10 times itself a negative amount of times to get to a 0.5. Interesting. Okay. Next page. What happens when you take the log of a negative number? And the answer is you can't. And what is that telling you? It's telling you that no amount of positive numbers can be multiplied by themselves to make a negative. Right? There is no answer for the log of -1, because you're saying to the calculator, hey calculator, how many times would I times 10 by itself and end up at -1? And the answer is, even if you took a fraction of 10s times themselves, the answer is there's just no solution. I shouldn't use a not equal to sign. That means something else. Undefined. Okay, and what is the log of 0? Well, the log of 0 is 1, and what do you think that means? It means that 10 to the power of 0 is 1. So let's see, right? Show that again. Log of 0 is, oh, I'm sorry, wait a minute. Oh, I'm sorry. Ah! No, log to the base of 0 is not 1. That's also undefined. Sorry. I was thinking, what's the log of 1? Log of 1 is 0, right? So I did mean to talk about this. 10 to the power of 0 is 1. So that means that 10 to the power of what makes 0? Well, again, it's telling you that x doesn't exist in this case. So no amount of 10s multiplied together will produce 0. Okay, number 7. What does it mean to take the log of a number? Well, I kind of answered that on the other page. I kind of forgot this question was coming. So basically it means how many 10s multiply together to make the number you are taking the log of. And your English teacher is going to be very upset that I ended that statement with a preposition, but oh well, this ain't LA class. So that's what it means to take the log. It means you're asking your calculator, hey calculator, how many times do I got how many times do I have to multiply 10 by itself to make this number? So that's why the log of 100 is 2, because 10 times 10 is equal to 100, right? 2 of them. Or, better explained, because 10 to the power of 2 is 100. That 2 is why the answer here is 2. Finally, why can't we take the log of a negative number? Hint, what happens when we try to put a number into the power of a negative exponent? Well, we can't take the log of a negative number because, say for example, again, log of -1 is asking the question, how many tens would multiply together to make -1, right? And even if I times 10 by itself, even if I took a root of 10, a half root, square root, third root, fourth root, it wouldn't matter. There's no fraction small enough that I can put into this to make this true. X is undefined. All right, so that was kind of our introduction to logarithms. We'll start with the more formal lessons on it next time. See you later.